How do we contact each other? Now it's been recorded. So how do dolphins communicate? They contact each other. They have blowholes to make different noises. So instead of vocal cords, they have got blowholes, and these blowholes produces whistles, sometimes squeaks like rats, and at times it produces ultrasonic waves or sound like bats, very high pitch, and which we cannot hear, but dolphins can hear. Okay, we cannot hear neither infrasonic or ultrasonic sound. And the specialty about these sounds is that dolphins, there are so many dolphins, right? So they can identify who are being called, who are being contacted. They can understand very nicely. That's why we call dolphins are very intelligent animals, right? So see how they're singing to each other? They sing to each other. See, whales are singing to each other. And we also know that sound can travel through water. Sound can travel through water. You understand?
Yes,
This is
ma'am.
how the waves this is how the waves are produced. If a sound is produced from top, maybe from the ship, this is how it goes. Okay, like this. And how do we come to know what is the depth of the sea? Because of the distance which is covered by the waves. So it strikes, this is the bottom, for example, it strikes over here, and then again it goes back like this. It goes back, and then it is received. So they can identify, they can find out what is the distance between the ship and the bottom. You understand? So they can find out the
Yes,
distance
ma'am.
between the ship and the bottom of the sea. You understand? This is the mechanism. We'll talk about it later in detail. Okay. Now we'll do an activity to show that sound needs medium to travel. For example, you can hear me, right? Right now you can hear me, isn't it?
Yes.
So what is the
Yeah.
medium that we are using right now, Vita? What is the medium that we are using right now? It is the electronic medium, right? The mobile. It is the
Yes.
electronic medium that you are able to receive me. But if there would not be the mobile and I'm in your class and you are hearing me, what is the medium that is in the class then that you can hear me?
Sound.
No, sound is the agent, beta. Sound is that you are hearing. Why are you hearing? So I'm talking about the medium. I'm talking about the agent. Air. Presence of air makes you hear me. If I remove air from the classroom, I make it a vacuum. What is vacuum, beta? Vacuum. What is vacuum? Minus air. You got it? What is vacuum, beta?
Minus air.
You understood now? Presence of air and absence of air. So absence of air is vacuum. For example, in the space. Do you think we can hear anyone in the space? No, because it's a vacuum. There's no air. You understand? And that's why they take the cylinder with themselves. Got my point? You have seen people carrying cylinders when they go for mountaineering? Yes or no? Because as you go up, the air becomes thin. You are not able to breathe properly. So you need cylinder. You need more of oxygen, isn't it? Are you getting my point or not?
Yes, ma'am.
So you can hear me by because there's a presence of air. If I remove air,
Yes.
you won't be able to hear me because air needs a media to travel. How will it travel if there's no air? Isn't it? So particles are must. So air has got particles. So my voice will hit those particles and that particles will hit another particles. You getting my point? And it will reach you. So this is the way it goes. It goes like this. So if it's me over here, I'm A. So the waves go like this, and you are here B. You got my point? And it reaches you. It's a wave mechanism. It moves like a wave. You understood all of you? That's how the sound travels. And this is air. Got it?
Yes, ma'am.
All of you understood? Okay, fine. Now please read.
Yes, ma'am. From where?
Yes, you can start reading.
Okay. Sound needs medium to travel. Sound is a mechanical wave and needs a medium from uh, propagation.
It's
Sound
for.
travel.
It is not from, but it is for
Yeah.
propagation.
For propagation, sound travels through solids, liquids, and gases. Sound does not travel in vacuum.
This is
Activity.
confirmed. Just a moment, Peter.
Yes.
This is confirmed.
Yes.
Yes, it's a mechanical wave. See, I'm talking, then only you can hear me. If I don't speak, can you hear me?
No.
So it's mechanical. I'm doing it. I'm taken as a machine. Now I ring a bell. It is mechanical. Yes, I press the doorbell. It is mechanical. It's all machine. So we are also a machine, I think so. What do you say? So it's a mechanical process. Until you do, you cannot hear, right? So it needs a medium to travel. What is propagation, beta? What is the meaning of propagation? Travel, to move forward. And from where does it travel? It travels to all the, what is this? Solids, liquids, and gases, beta? All the matters. Hello, can you hear me? Can you hear me, beta? Hello?
Yes, ma'am.
You can hear me.
Yes,
Oh,
ma'am.
what are these? These are all matters. Three matters of these are the states of matter: solids, liquids, and gases. So sound travels through solid. You know that sound travels through liquid. We just came to know, and we also know sound travels through gases, means air. Got it? So we know all these things, but it does not travel through vacuum. This I told you just now. This much is clear.
Yes, ma'am. Yes.
Now we'll do the activity to show that medium is a must for sound to travel. Yes, better start.
Okay. Activity. Suspend an electric bell in an airtight bell jar. Connect the bell jar to a vacuum pump. If the switch is pressed, we can hear the sound of the bell. If air is pumped out through the vacuum pump, we cannot hear the sound of the bell. This shows the sound needs a medium to travel and sound cannot travel in vacuum.
Thank you. Now see over here. Now this is the bell jar. So what is this beta? This one? I will show you one by one. This is the bell jar. Can you see this beta?
Yes, ma'am.
This is the bell jar. And this is behaving like a electric bell. The whole system is behaving like a electric bell. Then we have at the bottom vacuum pump. Because we have to show the activity that a medium is a must for sound to travel. So we have created a vacuum, we have adjusted rather, we have connected a vacuum pump to the system. One we will do with air and one we will do without air. That's why we have put the vacuum pump. So In this case, when there is a air and we have put a clock, okay? So you can see, you can hear the tick tock of the clock, table clock, yes?
Yes, ma'am.
Yes, you can hear the table clock, the tick tock of the table clock when there's air inside the bell jar. What we do? We remove the air with the help of vacuum pump. When we do it, see, the clock is working, the clock is working, but we will not be able to hear the tick tock sound when the air is removed from the bell jar with the help of vacuum pump, suggesting that medium is a must for the sound to travel. Understood this much better? Hello? Hello? Can you hear me better? Hello?
Yes, ma'am.
Yeah, can you hear me?
Yes, we can.
Okay, did you understand what I said just now?
Yes.
So what is suggested over here? That air is a must for the sound, and when we remove the air with the help of vacuum pump, we cannot hear any sound of the clock. Any problem?
No, ma'am.
How sound travels? Please.
Okay. Propagation of sound. Sound requires a medium to propagate. Sound travels through solid, liquid, and gases. Sound does not travel in vacuum. Example, sound travel through the solid thread of a CAN telephone. A whale listens to the reflected sound echo in water to locate its prey. We are able to listen the sounds because sound travels in air, a mixture of gases.
First one, see, this para sound requires a medium that was already in the earlier slide. Remember, you read it out. It's a repetition, is it? This is for revision purpose. I've taken the slide. But you will come to
Yes,
know something new, something more than the earlier slide. Sound travels through the solid thread of a CAN telephone. You know what is called CAN telephone? I will show you. See, this is CAN telephone. This is a small matchbox or a can you take, a steel can. Uh, what you use it as Coke or Coca-Cola. You get those small cans, remember? You make a hole and there's a string over here. And you put a can over here, and she is also putting a can on the mouth. So the thread is the medium of propagation of the sound which is created by A and is received by B. I wonder whether you had played this game when you were pretty young. You're still young, you can do that as well. So if I speak and there's a thread attached with my can and yours can, you're putting it on your ear and I'm putting it on my mouth. I say hello, that hello will travel through the string to your can and you will be able to hear my hello. You understand? So what does it suggest? Solid.
yes,
So so what is traveling? So sound is traveling through what? Through the string. Sound is traveling through the string and that is solid. Understood better? So that's why they have written it as can telephone. You know can? Can is a small, what do you call it? Small bottle but tin bottles. That is called as can. Bottle, can bottle. Okay? Steel bottles or aluminum bottles. Now a whale, what does it do? Whale gives out a sound, okay, and then it comes back like this. So it is an echo. You know what is echo? You go to a mountain or you go to a very old monument and you said hello, and that hello comes back to you after some time. Have you ever observed these phenomena, girls? Have you ever
Yes,
heard?
ma'am.
So that is called echo. What it is called, Vita? Echo. That
Echo.
your own sound comes back after some time. So how does it happen? It goes here, then it comes back. So the sound which gets reflected is called as echo. You got it? Yes? Understood better?
Yes, ma'am.
So this is the way a whale, a bat. You know what is bat? We talked about it, I think, yesterday, not yesterday, day before yesterday. Uh, how bat gives out ultrasonic, and if this is a wall, it hits the wall and then it comes back to the bat. And the bat can come to know what is the distance of the wall or the prey. So it can go and uh, swirl, or it can take a curve without being hit by the wall, or if there's a prey, it can go and eat the prey. You understand? Prey is something which you eat. The animals, they eat their prey. They kill their prey. I think you know that. Yes? So what whale does? Whale listens to the reflected sound, that is echo, to find out where its prey is lying. So it can go and eat the prey. We know that air is a mixture of gas. Yes or no? Air has got, yes, tell me, air has got carbon dioxide, it's got nitrogen dioxide, it's got sulfur dioxide. All these gases, when they combine, they form air. And we are able to listen to each other because we have presence of air in the atmosphere. So sound can be heard because sound needs a medium to travel and it has got air to travel. See, this is how whale gets the fish. This is the fish. So what it's doing, see, it is giving out the waves. Can you see this? So the waves are hitting the fish. So you can see there's a space over here. Can you see the space? Girls, can you see the space better? You cannot see any waves over there. And now it hit over there, and now what happens? These are the reflected waves. Got it? So it can find out where the fish is. It can measure the distance where its prey is lying. This is how we produce waves. Can you see this? Girls, can you hear me?
Ye- Yes, ma'am.
So this is how, see, when we speak, we give out waves. Can you see this? We give out waves. Got it? And this is how you receive, you hear. These waves are received by your ear and you can hear me. You understand?
Yes, ma'am. Now we talk about speed of a sound. Please start.
Please start to read better.
Okay, ma'am. Speed of a sound. Speed of a sound depends on the elasticity,
Elasticity.
electricity, the ability of an object or material to resume its normal shape after being stretched or compressed, the density of the medium through which it propagates. In the case of air, it also depends upon the temperature of air. The speed of sound through air is about 330 meter speed
Per second.
this second, yeah,
330 meter per second better.
per second. The speed of sound through water is about 1500 meter per second. The speed of sound is solid liquid.
No, no, no. Say that the speed of sound in
The
solid
speed.
is more than liquid, which is
Okay,
more than gases, right? So you
okay,
can see the mathematical notation, beta. So you have to
yes,
say solid is greater than liquid is greater than gases. Yeah.
yes. I
So
have
where is the speed of sound maximum? The speed of sound is maximum in solid, followed by liquid, and then gases. This is how
gaseous.
you have to
Yes.
speak out.
Okay. The speed of sound in gas is least.
That
Um,
means it is the minimum, right?
yes. Relationship between speed,
Speed, frequency, read with me. Speed,
speed
V,
v,
frequency lambda, sorry, frequency nu,
frequency
frequency
nu.
nu, and wavelength lambda. You are not able to read, I know. That's why I'm
Yeah,
helping you out. So
yeah.
relationship between speed V, frequency nu, and
Nu.
wavelength lambda. Now you
Okay.
read it out. So speed is equal to
Speed is equal to wavelength and frequency. V
into
equal,
frequency.
ma'am, how to pronounce this word?
Lambda, lambda,
Lambda
lambda
and lambda
into
into
nu.
nu.
This is how you have to pronounce nu, N-U. This one, nu.
Okay.
It's like this. And lambda is Lambda. You got it? Lambda. So this is lambda. You understood? And this is nu. How you pronounce NEW, new, right? Same thing has to be done over here. So what is the relationship that we observe over here, beta? V is equal to, that is the speed is equal to nu lambda, that is frequency into wavelength. Any problem so far?
No, ma'am.
So I will repeat the same and explain to you. What we observe over here, that the speed of a sound depends on two factors. First one is elasticity and second is density of the medium. Okay. Now what is elasticity? Now let's take a rubber band. Yes or no? Take a rubber band, you stretch it. So we say, oh, this is elastic. Some you can stretch nicely, some you cannot stretch. Am I right? Hello, girls. Girls, do you agree with me?
Yes, ma'am.
Yes. So you stretch a rubber band and then it comes back to its original shape or position. Is it okay? You use the rubber band, isn't it? Sometimes you stretch it very much. Then sometimes the shape of the rubber band gets deformed. Yes or no? Sometimes it breaks. Yes? Say something better. Hello? Girls, do you hear me?
Yes, ma'am.
Hello? Yeah. So now if you take a spring and you compress it, you press it. Compression is press it. You press the spring, when you leave it, it comes back to its original shape.
Yes.
You observe this? Okay.
Yes,
So
ma'am.
does it? Come back to original shape, depends on the elasticity of the object. You agree with me?
Mm.
If
Yeah.
you stretch, it comes back to original position. If you compress it, it comes back to the original position. Yes or no? I gave you two examples. One is rubber band, another one is spring. Yes? So that is the elasticity of the object. Second is density of the medium. Medium is what? Solid, liquid, and gases. If I ask you what is density? Density is mass per volume. You know that, right? What is density, beta? Mass per volume. So, which one has got main maximum mass? We'll talk about solid. So, solid will have more density. Yes or no? As compared to water, as compared to gas. Do you understand what I'm saying? Which has got more mass? Solid, liquid, or gas? It is solid. Solid has got more mass, that means density is more as compared to water. Water has got more density as compared to gas. Do you agree with me? Excuse me. Girls, do you agree with me?
Yes, ma'am.
Yes? Did you
Yes,
understand what
ma'am.
I said just now? So which has
Yes.
got more density, beta? Which has got more density? Hello? Which has got more density, beta? Can you hear me or not?
Yes.
So which has got more density, you say? Is it solid, liquid, or gas?
Solid.
Solid. Followed by liquid, and then it's followed by gas. So maximum is solid, then comes liquid, and then comes gas. So gas is the least. Now sometime in gases condition, say air, they say temperature also becomes a factor because you know that hot air is lighter than the cold air, isn't it? Hot air is lighter than the cold air. So sound will travel more where? Hot air obviously as compared to cold air. And what is the speed? This is what you have to learn by heart. The speed of sound through air is 330 meter per second. You have to remember this throughout. And through water is 1500 meter per second. So which is taking less time, better? Hello? The speed of sound through air is about 330 meter per second. The speed of sound through water is about 1500 meter per second. So, what is happening? Through gas, it is the least as compared to water. See, how much distance is traveled in water? 1500 as compared to 330. Can you imagine? Per second, this much is being traveled. The sound is traveling, per second, this many meter. That's 1500 meter as compared to only 330 meter in gas. You can very well imagine how fast it is traveling in water. Hence, they have come to a conclusion that the speed of sound is maximum in solid, followed by liquid and then gases. Gas has got the least. The speed of sound is the least in the gas. And the relationship that we observe in this regarding speed of sound with wavelength and frequency is V is equal to nu lambda. When nu is frequency and lambda is wavelength and v is the speed of the sound. Any problem? Yes, but any problem?
No, ma'am.
Understood nicely?
Yes.
Yes.
Yes,
Want to
ma'am.
ask me any question? You can.
No, ma'am.
So these are the random so data which shows the speed of sound in different media at 25 degrees centigrade or Celsius. If it is solid, you can see aluminum, steel, iron, brass, glass. These are the speed in meter per second. You can see from 6,000 to 3,000 is the range in solid. Whereas in liquid, it starts from 1,500 to 1,100. You understood? Now we come to gas. It starts from 1,000 to 200. You understood? See how it is decreasing? The solid we got 6,000 all odd. In liquid we got almost 2,000. In gas we got almost around about 200, 300. Hydrogen has got the maximum, that's 1,284. Rest it has come down to 213. That is sulfur dioxide. You understand now? You can see the data showing that solid has got maximum, followed by liquid, and then gases. Did you understand? Hello, did you understand better?
Excuse me, ma'am.
Yes?
Lecture is over.
No, I know that. I'm not carrying forward, but I know that. I'm keeping it right. Thanks for reminding. But did you understand whatever I showed you just now?
Yes, ma'am.
Yes. All of you?
Yes, ma'am.
Okay, beta. And please revise it. Today, most probably, I will give you the textual question of lesson number 12. And start
Okay,
Okay.
ma'am.
revising right away. Okay, beta?
Okay, ma'am.
Okay. And whatever I've given, please give it to the follow-up teacher or Ruby ma'am. Please show it to her that you have finished with the assignment. Okay? Okay, beta? Assignment is your homework, I think so. You should understand. So
Yes.
have a good time. Enjoy your weekend and be good to yourself. Bye, beta.
Bye, ma'am.
Bye, ma'am.
Bye, beta.
Bye, ma'am. Bye, ma'am.
Now which lecture?